or issues before we start?
No, sir. We are going live right now.
Okay, that is YouTube. Okay.
Yes.
Suresh sir has not joined yet.
Suresh is having problems, so there's nothing we can do.
Samir also waiting.
Yeah. So somebody please be on top of the waiting room.
Yes, sir. I will do that.
Dina, I think you can start. You have 1 minute to the top of the hour. 6 o'clock. Dina, are you muted?
No, sir. I was just waiting for the 6 o'clock.
Okay. Okay, sure.
So just start now?
I think you can get started.
Okay, sir. Honorable dignitaries and fellow members of the IEEE fraternity, a very good evening to one and all. Welcome to the 5th edition of IEEE RAICS 2020, an international conference on recent advances in intelligent computational systems organized by the IEEE Kerala Section, and for the first time ever in virtual mode, spanning from this very moment until the 5th of December 2020. This flagship event of the IEEE Kerala Section that caters to the frontier areas of intelligent computation and its diversified applications in various fields of technology is based on the theme Computational Technologies for a Healthy Humankind. Attended by dynamic techno enthusiasts, IEEE RAICS 2020 is a culmination of several interactive virtual keynotes by some of the best minds in technology, alongside panel sessions and technical tracks. It marks a technological tinkerer's opportune moment to be a part of integration of information, inspiration, and collaboration. Without further ado, to welcome you all on this glorious occasion, it is my honor to invite one of the pillars of support of IEEE Kerala Section, Mr. Satish Babu, the conference chair, to give the welcome address.
Thank you, Dina, and good day from Trivandrum, India, and welcome to the inaugural session of RAICS 2020, the 5th biennial technical conference of IEEE Kerala Section. First of all, a warm welcome to everyone who's been able to join our Zoom and YouTube rooms. We are acutely aware that around the world we are passing through very trying times. But at the same time, we note that the science and technologies that our community deals with has become indeed very important. The internet and different computational technologies have been the most significant lifeline that has kept people and economies working through these very uncertain times. Even prior to the pandemic, the pace of technological innovation has been rising. The pandemic has further intensified its speed, with innovations feeding into each other and multiplying and enriching each other. This frantic pace of change raises challenges not only for manufacturing and applied technology sectors, but also for academia and research communities. Technical conferences are, of course, one of the ways to disseminate these developments to communities. And IEEE has always been at the forefront of dissemination of scholarly information. A decade back, IEEE Kerala Section realized the need for its own technical event to provide a platform for dissemination of emerging developments among local and global communities. This is the reason the section set up its biennial conference series, RAICS, which is Recent Advances in Intelligent Computational Systems, 10 years back. The current edition, RAICS 2020, is its 5th edition, and given the global pandemic, it was decided to organize it as a virtual event for the first time. And the theme has already been mentioned is Computational Technologies for a Healthy Humankind. My colleague Bijuna will provide more details on RAICS 2020, and I'd like to briefly welcome the dignitaries for joining us, sometimes from very inconvenient time of day, just to be talking to us. First, I'd like to welcome Dr. Michael Leitner, past president of IEEE, and indeed a very good friend of IEEE Kerala Section. Thanks for joining us to deliver the inaugural address despite all the difficulties, and welcome back to Kerala once again, Mike. I'd like to welcome Dr. Bridge N. Singh, John Deere Fellow and globally renowned power electronics professional, who joins us from North Dakota. Dr. Singh will be delivering the conference keynote address today. I join all of us in welcoming Dr. Singh to RAICS 2020 and to IEEE Kerala Section. I'd like to welcome all my colleagues who are going to speak today or in the other sessions next 2 days, or have been working hard behind the scenes to put this conference together. I'd also like to welcome all speakers, paper presenters, reviewers, volunteers, Kerala Section Execom members, and everybody else who has joined us electronically today. I hope that the papers presented at RAICS 2020 will advance the body of knowledge in these domains and stimulate further work, particularly within the student community, and eventually realize the IEEE tagline of advancing technology for humanity. Thank you and stay safe. Back to you, Dina.
Thank you so much, sir, for your warm welcome. Next up, I would like to invite Dr. Bijana K, Technical Program Committee Chair, to give a brief overview of the conference.
Good evening, President of the function, Ms. Sharka Jayakrishnan, very special guests, Dr. Michael Leitner and Dr. Bridge N. Singh, and the esteemed executive members of section, the delegates, reviewers, and all supporters of IEEE Kerala Section. This is the 5th edition of RAICS 2020, the flagship conference of Kerala Section, which we decided to go virtually, especially only because of the pandemic. And so the theme was developed as computational technique for healthy humankind. Based on this theme, the tracks were identified on the cutting edge technologies itself of signal processing, healthcare, devices, systems and technology, robotics, automation and control, energy systems, IoT, data analytics and machine learning, energy systems, advanced computation for engineering applications and technologies for societal applications. This time we decided to have each of these tracks as handled by a society chapter of the section. And so we had so many society chapters coming in line and collaborating with us. So we thank all the society chapters, Engineering, Medicine and Biology, Signal Processing Society, Computer Society, ComSoc, the Communication Society, the Robotics Society, RAS, PES, the PES, Power and Energy Society, the Industry Application Society, the Industrial Electronics Society, PALS, or Power Electronics Society, as well as the SSIT, the Social Science Implications team, as well as the site. So we had the keynote addresses also coming in line with the same tracks. So to start with, today we have the inauguration being done with our Mike Leitner, a very good friend of ours. He has been to Kerala several times. Thank you, Mike, again for being here. And we have the conference keynote being made by Dr. Bridge N. Singh, John Deere Technical Fellow, who's actually an expert in power electronics and is going to talk about the wide bandgap power electronics for heavy duty vehicles, particularly. And we have the next keynote by Dr. Ashokan T, the head of the Department of Engineering Design, IIT Madras. He's going to talk about the control of autonomous robots for field and science applications on 4th December, that is tomorrow at 2 p.m. Indian Standard Time. And immediately after that, we have the parallel paper presentations in 3 separate tracks. The next day, 5th December, starts with the keynote address by Dr. Shiju Esses. He is the architect in AI and automation of Litmus Systems Consulting Limited, Kochi. And he is going to talk on time series forecasting using deep learning technique. And that happens to be at 9:30 a.m. Indian Standard Time. And it is followed by another fantastic talk by Mr. Paras Lumba and Jaideep Bansal, who are the people behind the Global Himalayan Expedition. And they are going to talk about a really interesting topic of transforming the Himalayas through culture and technology. We have the fifth keynote by Dr. Jairaj Joseph. He is from the Department of Electrical Engineering of IIT Madras, and he is going to talk about the creating impact through collaboration, technology, and innovations. And in spite of all of them, we have the parallel paper presentations on 2 more sessions on December 5th. And another key item that we have on the 5th December is a special IoT session, which is actually handled by the IEEE IoT Initiative Board. And we are lucky to have been represented by Dr. Henry Sturgeon, the director himself, then Professor Venkatesh Prasad, who is going to talk to us on unlicensed LP WANs connectivity. We have Dijan Malogistic. He's also going to talk to, he's actually from HP Labs. Dr. Adam Robot, the IoT verticals, is also representing the industry. And the other academician from our side, Mr. Srikant Chandra, Dr. Chivan Chandrasekharan, who's going to talk about the impact of IEEE standards on Internet of Things. So we are trying to present to you a perfect mixture of technology in all the dimensions of IEEE, which we have been looking at. So thanks to all the delegates who have actually sent the papers and has come over to present the paper here. And welcome all the delegates, welcome all the keynote speakers, and welcome all our ExCom members as well as well-wishers of IEEE Kerala Section. Thank you.
Thank you so much, ma'am. Next, I feel privileged to invite the chair of IEEE Kerala Section, the Sharada J. Krishnan, to deliver the presidential address.
Thank you, Dina. Good evening, good morning to all who has joined this inaugural ceremony today from across the world. Thank you, Dr. Leitner, for joining, for inaugurating this event. Maybe after a long time, I think you have been participating in an IEEE Kerala Section event. So welcome. Also, Dr. Bridge, thank you for joining as a keynote address. So, as was mentioned, it is a proud privilege that we could host the IEEE RAICS, the 5th edition of it, in a virtual mode completely. I'm actually sitting right now at my home, just got back from office, so that I could be part of this event and also look at the various 3 days of program that has already been highlighted by Bijna. So as was mentioned, computational technologies for a healthy humankind, what better time than now to pick topic when we are in the cusp of probably having discovered one or two possible vaccines, and also coming to better understand this tiny virus that has been, attacking us. It is also indeed very good time, in the sense that every industry is currently sitting back and having a rethinking about what is the way to move ahead. I'm sure this is not specific to any special industry. It is across the industries that there has been a kind of opportunity to sit back and think on how to move ahead. And that is when the special requirements related to IoT, computational technologies come into relevance. And also to think that we need to look at humankind as such before moving ahead at the paces that we were moving so far. So a very apt theme, and also this time, as was mentioned, we had tried to have all the society chapters that currently Kerala Section has to participate in through this conference. So it's a wholesome conference of IEEE Kerala Section, and as being part of the ExCom, I'm really privileged to be out here. Thank you for the whole team led by Satish, then Bijuna on the program side, and many others to make this event today, starting today. The D-Day has finally come in. So all the very best for the conference and also the deliberations. I'm sure the participants are going to be really rewarded by attending this one. Thanks again to all the speakers who had kindly consented to be part of this conference. Thank you. Over to you, Dina.
Thank you so much, ma'am, for your enlightening words. Today is special, not only because we are inaugurating IEEE RAICS 2020, but also because we feel honored to have with us our Honorable Chief Guest, Dr. Michael R Leitner, Vice President of Academic Affairs, University of Colorado, System Professor, Electrical, Computer, and Energy Engineering at University of Colorado, past President of IEEE, Life Fellow of IEEE, and Fellow AIMPE, and someone who is very close to IEEE Kerala Section and has visited our section twice in the past. He is a man of distinct vision who has led IEEE at the forefront in transforming lives and inspiring future innovators with his distinguished work in numerous capacities. It is an absolute honor and privilege for me to invite Dr. Michael R Leitner to deliver the inaugural address.
Thank you very much. Let me share my screen and there. So I want to focus today on the theme of the conference, the computation technology for a healthy humankind, and begin by first congratulating all of you. Congratulations for putting on a virtual conference, for carrying on the tradition of RAICS, and for doing it not only in the pandemic, but also with a cyclone due to hit Kerala, in a few hours, sometime this weekend. So congratulations to all of you. And then greetings, really friends, colleagues. I have such fond memories of all of my friends in the Kerala section, of Kerala itself, of visiting. It's been very much too long, and I'm sorry I can't be there in person, and hope that you are remaining healthy in these challenging times. A sincere thanks to my friend, the conference chair, Satish Babu, for his invitation to address you, and welcome to this exciting conference. Your timing, of course, is perfect, because if this was March, when everybody was just figuring out how to use Zoom and how to be effective on Zoom, it would be very hard. Not that it isn't difficult now, but we spend our time on Zoom, unfortunately. I spend my time on Zoom, and this is a very common and easy format for us now, and I'm sure that you'll do a wonderful job throughout the conference. So, in thinking about the conference, there we go, I asked myself how to inaugurate this when it's such a broad theme, right? Look at all of the areas that you just heard about that'll be part of the technical conference. And certainly I don't want to talk about them, because I could be talking about brain-computer interfaces or bionic people or MRI machines, or really, let's talk about vaccines, and how do I give a vaccine, and how can I make sure that it works, and what are the effective technologies for that now, because there are many. But no, that's not the way that I should go as an inauguration. And so what I wanted to do was to raise a meta question around your theme. How do we measure progress and success associated with healthy humankind? And that led me to ask the question of, what does it mean to be healthy? If we're looking at our technologies generating and supporting a healthy humankind, we've got to ask ourselves, what does that mean? So it could be physical, emotional, intellectual health. It could be spiritual health. It could be economic health. It could be the health of our family, our community. How do we fit in socially? And so let me raise some of the challenges that we have just trying to say this. So here we have a person who, was using rollerblades and broke their arm. Are they healthy? They have a broken arm, but they can get around, they can eat, they can do their job, let's say. You tell me, are they healthy or not? How about this person? Extreme poverty, homelessness. Well, if we talk about economic health, if we talk about community health, maybe this is a situation where the person is not healthy. Here, severe depression. Severe and persistent mental illness is a problem in all parts of the world. And if we look at emotional and mental health, then this is clearly a challenge to health. Okay, these are maybe depressing pictures. How about something happy? All right, so here we have a traditional image of a happy, healthy family. Okay, that's great. What about this family? Young daughter, you can see on my left anyway, I'm not sure how it appears on your screen, had damage, genetic damage to chromosome 21. What that leads to, and what we call it around the world, is Down syndrome. Is she healthy? And if she's not healthy, how do we deal with it, and how do we incorporate her into our thinking about healthy humankind? So the first thing is, well, this is not easy. I'm not sure how to help us think about health and being healthy. So I went to the World Health Organization, and what they said in 1948 was that health is a state of complete physical, mental, and social well-being, and not just the absence of disease or infirmity. So if we look at this, clearly the person with the broken arm doesn't have complete physical well-being. So I guess they are not healthy. And we could go and look at this definition from the WHO and say, well, what does that tell us about some of these examples that I gave you? In 1986, in attempting to expand their definition, they said, oh, well, wait a minute. Health is really about a resource. It's being healthy as a resource for living well, and it emphasizes social and personal resources as well as physical capacities. For me personally, I'm not sure that helped a lot in terms of adding to the definition, but it gets better and more complicated, and you'll see that as we look at how things are progressing. But if we go back to 2009, in Lancet, the British medical journal, there was a paper where health was defined as the ability of a body to adapt to new threats and infirmities. So health wasn't intellectual health or physical health, intellectual health, economic health. It was, can you adapt? How can you adapt? And if you can't adapt, then that's a challenge, and that's not being healthy. If you can adapt, apparently you're being healthy. So, broken arm, no problem. Now, all of this is still a challenge for us in thinking about IEEE and our technologies supporting a healthy humankind. So I went back through history, and I found some quotes from various luminaries about health. So if we talked, what did Socrates say, for example? Socrates said, eat to live, not live to eat. Well, I like food, so I'm not sure. Mahatma Gandhi, it is health that is real wealth and not pieces of silver and gold. Okay, that's good. BKS Iyengar, health is a state of complete harmony of the body, mind, and spirit. When we're free from these disabilities, the gates of the soul are open. I really have problems with this. I don't know about you, but does that mean if I have a broken arm, the gates of my soul aren't open? No. Okay, well, I just disagreed with one of these famous people. How about another famous person, the Dalai Lama, who was asked, what surprised him the most about humanity? And he said, man. Because he sacrifices his health in order to make money. Then he sacrifices money to recuperate his health. Then he is so anxious about the future that he does not enjoy the present, the result being that he does not live in the present or the future. He lives as if he is never going to die and dies having never really lived. Now, these are just things that people were quoting about health, but they don't help us, right? We look at the WHO definitions, we look at the Lancet article, we look at these health quotes. How does that help us understand how we're going to support a healthy humankind? So then I went back to the UN, and I looked at the Sustainable Development Goals, and I asked myself, the goals that the UN has set forward, how do they impact health? Are they going to help us maybe define progress and success, because each of these has goals associated with them? Well, no poverty. Certainly if you're in extreme poverty, it's hard to be healthy, but not being in poverty doesn't mean you're healthy. Hunger? Yeah, right? If you have lack of access to food, it's very hard to be healthy. But if you have access to food, it doesn't mean you're healthy. Good health and well-being. Oh, well, there it is, right? One of the goals that we're interested in right there for us. And don't worry, I'm not going to go through every one of these, but look at some of them as we go forward. Think about clean water and sanitation. Absolutely. One of the major challenges worldwide to being able to have the basic requirements of health. Clean energy, we could talk about that and its impact on health. And of course, energy is one of the themes for the conference. How about sustainable cities and communities? Well, if you're not sustainable, then at some point, some portion of your population is going to be in either economic difficulty, in difficulty in housing, difficulty with work. How about this one? Peace, justice, and strong institutions. What does that have to do with a healthy humankind? And my first response is, if we're in a situation where we have peace and we have justice and strong institutions, one can argue that as individuals, we will have less stress. We will have more trust in the environment around us. We will be less stressed, which means less cortisol in our system, right? So you think about the response to stress, it's release of cortisol, and that is a damaging, over a long period of time, that damages our health. So here's an unexpected way in which one of the Sustainable Development Goals really impacts our individual health. And so the last one is one that is really important, and I think it's important in this conference because you're already doing it, but it's important to all of us. If we're thinking about a healthy humankind, we can't simply think about IEEE. We can't think about our technologies alone. We have to partner with people in healthcare. We have to partner with people in social work. We have to partner with people in psychology. Working towards a healthy humankind requires us to work in partnership. Oh, that's good. Great. Yep. Happy. Away we go. Except things are always changing. If we look at the picture in the upper right, you can forget most of the words. If you look at the picture in the upper right, what is that? That's a chromosome. What are these orange colors represent? That's the end caps of the chromosome. And what's important there? The telomeres. And we've learned that telomeres really impact how we age, how well we age, whether we get diseases or not, whether we're able to actually replicate our cells in a safe way. Then, many cases where individuals have been able to heal themselves or support the healing of themselves, even in difficult situations like cancer. And how do we frame that in our thinking about healthy humankind? And people are doing this not just by themselves, but in concert with, for example, chemotherapy. There's work for relaxation meditation during chemotherapy. The combination of the two is much more effective. Great. We've talked about broken arms. We've talked about a lot of things. What about your gut? What about your stomach and intestines? Said more scientifically, what about the human biome? And how that, what goes on inside our body is mostly not human cells. And the health of that human biome really impacts our overall health, the way we think, our behavior. And speaking of behavior, we used to think about music and we can calm down or we can be excited. We use it if we're exercising. But there's studies now about how the brain responds to music as if it were medicine. So the previous slides are all the easy ways to think about healthy humankind. And for me, that was hard enough. But all the work that's going on now is even more complicated. So what does it mean for us? We have to keep doing the research you're doing. The work you're doing is great. We have to consider all the things you're doing in the conference. They're important. They'll impact people's lives in a positive way, whether that's from making agriculture more effective, workplaces safer, any of the things that actually come out of this work. You know, an old cartoon about telehealth or telemedicine. But health is more complex than we typically acknowledge. It's more than the allopathic Western perspective. It's more than the physical body. It's more than the individual. And our understanding of it is constantly evolving. So as we think about using and applying our technologies, we have to keep a broad eye out for changes to our understanding in health and how we can really support a healthy humankind in a variety of ways, not just in mainstream areas, but maybe in what might be considered fringe or new areas or traditional areas that continue to be important and understood in new ways. So a few headlines over the past 4 or 5 years, how our sense of touch affects everything we do. Wait a minute, I haven't talked about touch at all. In any of this framing, I didn't say anything about touch. Loneliness. Loneliness rivals obesity and smoking as a health risk. Okay, what are we going to do about loneliness? Well, we have a Zoom meeting going on where we couldn't even talk to one another beforehand. Homelessness and health. Huge connections there. And then, maybe the joy or the bane of our current existence, there are complex links between social media and mental health. Certainly we were seeing that in my country with respect to the last election. Just remarkable. So, progress, we have to do what we're doing, but we must, and I really encourage you to try to frame your work either qualitatively or quantitatively in a larger framework. That could be the Sustainable Development Goals. It could be something else. That's entirely up to you. But also, when you're teaching about the applications to a healthy humankind of all the great technology that you're working on, when you're writing proposals for research for funding, writing papers, take the time to place your work in this non-technical framework as well as in the technical framework. And the non-technical framework is the motivator, right? Healthy humankind. And always keep in mind that last Sustainable Development Goal. In order to make this happen, we have to work in partnership. We have to have teams that are beyond our own disciplines, and we have to work with them, and we will make such a difference, such an impact. So, thank you. Thank you for your attention, for being at the conference, for inviting me to address you with these short remarks, for the work you do, and for caring about a healthy humankind. And I wish all of you the best. I wish 2020 RAICS a great, successful 3 days of a conference. I hope to join at various points. And thank you all again for the work you're doing, for carrying on, even in difficult times, the important keystone of IEEE, which is our technical work and the conferences that we have to share that work with one another. With that, I turn it back to the conference organizers. Thank you very much.
Thank you so much, sir, for your words of wisdom. Next, I would like to invite Dr. K. Suresh, Publication Chair, to expound upon the conference proceedings.
Yeah. Good evening. Uh, so we are about to release the conference proceedings. So we have included 40 papers, all the registered papers in the proceedings. And I would like to thank the conference proceedings team, Dr. Jason, Dr. Bobby, and especially our volunteers, Abhirami and Gokul, for bringing this proceedings on time. Thank you. And I wish all success to the conference. Thank you for all the participants, all the registered participants for sharing their work in our conference. Thank you.
And I believe it's now my honor, privilege, and pleasure to declare the conference proceedings published. Congratulations.
Thank you very much, Mike.
Yeah.
Thank you so much, sir. Thank you so much, Michael, sir, for taking time out of your very busy schedule to grace this occasion with your esteemed presence. You're indeed an idol of knowledge and a guiding light of IEEE. On behalf of IEEE Kerala Section, we would like to present a small token of appreciation from our side for your illumination.
Hello.
Yeah. Okay.
Yeah, Suresh sir, you can go ahead with the proceedings.
Yeah. Okay. Yeah. Just okay. I hope it is visible.
Yes.
Yeah. I'll just all the plenary talk abstracts included, and schedule, and actually I'll just show one paper. Okay. Yeah. Yeah. Okay. Thank you.
Thank you once
Okay.
again, sir.
Yeah. Thank you.
Michael, sir, once again, I would like to thank you so much for taking your time out of your very busy schedule to grace this occasion with your presence. You're indeed an idol of knowledge and one of the torch of guidance of IEEE. On behalf of IEEE Kerala Section, we would like to present a small token of appreciation from our side for your kind support.
Thank you very much. It's been a great honor and pleasure to be able to be with you today, and I look forward to the time I can see you all in person again.
Thank you once again, sir. Next, I would like to extend my invitation to Mr. Suhair A.K., Chair, Best Kerala Chapter, to introduce our keynote speaker for the day.
Audible? Am I audible?
Yes.
Yes, sir.
Good day to all. We had a very interesting talk by Dr. Leitner just now. Thank you, sir. I consider myself very lucky to be part of this star-studded inaugural segment of RAICS 2020. Blessed with the presence of Dr. Michael Leitner, former IEEE President, Power Electronics Maestro Dr. Brijan Singh, and a galaxy of IEEE Kerala Section leaders. It's my pleasure and privilege to introduce the conference keynote speaker, Dr. Brijan Singh. Dr. Brijan Singh is a John Deere Technical Fellow in recognition of his significant contribution in power electrical engineering. As Region 4 Public Funding Manager at John Deere, he is responsible to connect with the reputed universities and track emerging technologies for adoption in John Deere products. He is an acknowledged leader in the power electronics products and technology design, development, and commercialization. He has 28 patents, one trade secret, and over dozen pending patents, all related to power electronics, technology development works, and project execution. He earned 3 innovations and 1 team collaboration awards in John Deere. He's chairing member advisory committee MAC in the Power America Institute. He's also the winner of 2020 IEEE Power Electronics Emerging Technology Award. We are very fortunate to have him to deliver the conference keynote. He'll be talking today on wide bandgap power electronics for heavy duty vehicles. I'm sure this talk will enrich the conference immensely. With all my best wishes, over to you, Dr. Bridge, for the much awaited talk. Thank you. Thank you very much.
Thanks so much, Mr. Suhair, and thanks for having me here. Before I begin my conversation, I just want to check that I'm coming okay? My sound is okay?
Yeah, it's okay, fine.
Okay. So I truly enjoyed talk given by Professor Leitner. It was really thought-provoking, inspirational, insightful, and motivational. So you guys, new researcher, can get a lot of tips from his wisdom. And I'm glad that he takes time and visit Kerala, so enriches India and for certain part of India. So I'm very glad, and we are connected with actually Colorado School. You know, John Deere works with. We are part of many centers in US. So maybe next time I'm in your area, I like to come and see you. Also, I like to thank Vijna being very patientful with me over many months. Mr. Satish Babu, IEEE Chair, and Dina and IEEE Kerala Section and the organizing committee. Thanks for having me. I'm going to share my screen and then we go from there. Let me know if it is coming.
Yes, sir, the screen is
good. Thank you. So today I would be talking about high temperature power electronics and why we are doing this project, and it was funded by US Department of Energy. And you will come to know a little later why US government want to invest into a new energy technology, green technology, to make the environmental sustainable farming sustainable, and green farming, carbon footprint reduction and things like that, and pretty much more or less like what the Professor Leitner has said, that you must be caring for environment, you must be caring for the places you live. So I'll talk a little bit about myself, and the reason it is because for a good power electronics engineer, you must know the environment you are living in and the environment your design and product are going to live in, because when we design a product, it remains in service for next 30 to 50 years. So John Deere has a history that if you buy some product from us, we would have a part for you. Even if you bought a product that was designed in 1930, you will get part from us. So what that means is we are committed to provide good service. Then just one slide, John Deere company, that would be like 180 plus year history of the company, but one slide is good enough to give the message. Then wide bandgap technology, followed by silicon carbide inverter technology for Deere vehicles. Then vehicle testing and some comment and summary. So this is about me. Certainly, I was nicely introduced by Mr. Suhair, but I was born and brought up in India. All my degrees are from India, and then I migrated to North America in '96, and with some stint in academia, I was assistant professor in Tulane University, New Orleans. Then John Deere headhunted me after Hurricane Katrina. And then currently I am a Region 4 Manager External Relationship, which includes public funding piece. and I'm mandated to establish John Deere relations in various universities, government agencies in these 4 countries. So it's pretty much like a global role. Mainly focus in US and Canada, but slowly I would be branching out to Australia and New Zealand. So this slide is extremely important to understand. If a good power electronics engineer must understand the temperature and the thermal cycling, because when the electronics is in use, it goes, extreme operating conditions, and temperature is one of them. So until 96, I was mostly constrained in the northern India. And as you know, some of you may know, in northern India, temperature gets extremely high in the summer months. So it is as warm as 50 degrees C. Then 96, I migrated to in Montreal, which is in Canada, and temperature gets as low as minus 40 degrees C, minus 45 degrees C. So you see right there, change of about 90 degree. And then in 2000, I migrated to New Orleans, where temperature gets 45 plus hot humidity and all that. And then so you see about 80-degree change. And now I'm in North Dakota, where in winter it gets as cold as minus 65 degrees C with wind chill factor. So again, you see about the change of about 100 degrees C. What you are seeing here is that thermal cycling, and that's exactly it happens when you are driving our vehicle. And if there's any power converter in our vehicle driving the drivetrain and electrified vehicle, that's exactly electronics sees the temperature, and every time it sees a delta T, it takes out a little life from the product. So if you understand this, then you would be designing your product for that condition. So just to give you idea that the electronics that I have designed for John Deere product have seen accumulative field hour about 75 million field hour and not a single failure. And that is basically, that comes with the mindset that you need to understand this very well, right? And John Deere loves his product quality, because we really want to be known as providing best possible service in the world. So this also slide is extremely important, and why John Deere is very relevant in US and world over. I made 3 major moves in my life. Warm Delhi was traded by cold Montreal, and then cold Montreal was traded by hot, humid New Orleans, and flood and hurricane of New Orleans were traded by cold, snow, blizzard, freezing rain of Fargo, North Dakota, minus 65. And in addition to that, very few people live here in this part of the world. Means, maybe Professor Leitner, you may know it very well, but, in North Dakota, you owning 5,000 to 10,000 to 50,000 acre farm is pretty much norm in like upper Midwest, like North Dakota, South Dakota, Kansas, Nebraska, in Iowa, Minnesota, those places. And there very few people are in farming. So that's where John Deere comes into play, that we make vehicle for farming application. You think of any farming operation, like right from tilling the ground to seeding to crop care to harvesting, and in real time doing a lot of computational and all that. Even as we drive this vehicle, we know all the soil chemistry, protein content in the grain, how many seeds we put on the ground, how they are spaced from each other, when the fertilizer is needed, what is the nitrogen intake, you name it, all that science. Agri farming is actually a science rather a business. And so that's where we come into play. We make lot of vehicle, many different form and factor. So another thing is that how tough people in North Dakota are. So this is my house far left in the backyard in the winter, and same backyard in the after blizzard or snow fall sorry, this is summer and this is winter and this is my front yard. So you could imagine that how hard people are, how tough people are in this part of the world. And I give you one example that in 2010, I was driving my company unit, John Deere unit in Fargo is about 6 miles away from my home. It takes about 15 minutes to get there from my home. And I in 2010, I was driving to the company from home, and a certain patch of the road, I just couldn't see even my car, right, front of my car. And I thought, oh my gosh, how I would make turn and how I would go. But eventually I made it to parking lot and found almost every spot in the parking lot was taken. Means this kind of condition is very normal for people. They just don't shut down. They just keep working no matter how harsh condition gets. And that's where the people who are in the farming in this part of the world, they are really, really very tough people, and they understand the conditions, and that's how they adjust themselves. So John Deere has been in business since 1837. So John Deere is a world leader in providing advanced products and services and committed to the success of those linked to the land. So we have a farming, we have vehicles for farming, we have vehicle for construction, mining, forestry, turf care, and all these vehicles are connected with John Deere network, right? So they are basically you can think of connected vehicles. So 5G and those kind of technology advancement are going to play significant role in the John Deere business. So this is the vehicle that I began working in 2007 as soon as I was hired by John Deere. So I just want to explain some of the things. John Deere has a YouTube channel. So if you want to know, as we make, we may be making 100 type of vehicles, right? Maybe 200 types of vehicle. Each vehicle is different from next one. So like in on highway, car is basically you are going from one place to another place, right? Without hitting anyone. In our vehicle, we must hit something. Like you are working in a concrete or you are working in a mining operation, you are going to hit some object. And then the one vehicle is different from the other vehicle, so you have to design vehicle specific conditions, or you have to consider the design criteria. But anyway, this vehicle has one electric motor on each wheel, and that electric motor has a 2500 Newton meter torque with 80 times gear reduction. So 2500 times 80 times 4. So roughly peak torque of this vehicle is 1 million Newton meter. And what that means is it has such a high thrust force that if this could operate 200 kilometer per hour or 300 kilometer per hour, probably it can fly, but it's not designed to fly. It is designed to operate for extreme torque condition, like you are hitting a big object and crushing them into pieces, right? Things like that. So this vehicle has my handprint, my mind print. And the electronics that I designed for this was basically designed to operate for continuously 22 hours a day, for 15,000 hours, which is 6 years. And we have already passed 8 years, means about 20,000 hours, and not a single failure. So what that means is that the product that we need to design these have to survive very harsh operating conditions, and like $1 million vehicle, right? So failure is not an option for us. If this vehicle goes down, it's a $3,000 per hour loss. So we just cannot even think about that this can go down. That's a mindset we have to use to design the electric parts for this vehicle. Now I'll switch over to wide bandgap technology, which is very new advancement happening in power electronics area. So gallium nitride and silicon carbide are two material, and this project was funded by US Department of Energy through Power America Institute. Little later you will come to know what is Power America. And actually what happened, with the some purchase, there was a company in the US called International Rectifier that has a significant presence in the US. After Infineon, which is German company, purchased it, after that pretty much power electronic supply chain has moved out either to Europe or to Japan or to China. So President Obama wanted to establish a new type of, technology, so that at least some of the, like a green technology, remains in US, particularly like electric vehicles and battery powered vehicle and things like that, hybrid vehicle, and of course energy efficient vehicles. So here, if you take the silicon semiconductor, silicon carbide semiconductor, and gallium nitride semiconductor and compare them with respect to these unique properties of these electric field breakdown and energy gap, and if you did so for a given electric voltage applied across the device, silicon carbide and gallium nitride can withstand higher electric field. So for a given voltage, if you could withstand higher electric field, means the device can be made thinner, like a 5 to 10 times thinner. And what that means is electron, when it's traveling from drain to source, when device is turning on and off, travels lot less distance. As a result, in on-state resistance is much less in case of silicon carbide and gallium nitride. What that means is conduction losses are about 1/5 to 1/10 as compared to silicon material. In addition to that, this is wide bandgap material, so the overall footprint means the heat per centimeter square you put heat on the material is 5 times better, 4 to 5 times better. So what that means is you can shrink the size of the device. Once you begin the shrinking the die size of the device, means the stay capacitance is much less. And once the stay capacitance of the device is less, it can turn on and off much faster rate. And once it is turning on at a faster rate, what that means is you can reduce the size of passive components. In power converter, the culprits are inductor, capacitor, all that. And if you begin to switch power converter at a high frequency, then you can pretty much eliminate either their size, their cost, their weight, and all that. And you can make the converter much smaller, means much less material used. And if much less material used, then you are mining less material from the mine, right? So it is good for environment. In addition to that, if you take the intrinsic charge carrier concentration, means when the voltage is applied and you are not basically getting the device, you are not applying the control signal, at that point there are very few electrons in the conduction band, right? Valence band and conduction band. As a result, there's very low leakage current. Means if you increase the temperature, still leakage current would be much less. So what that means is you can operate device at a higher temperature. You don't need to worry about leakage current issue as you were worried about in silicon semiconductor. Other thing that silicon carbide has, as compared to silicon semiconductor, has a 3.3 times thermal conductivity. So it has a material has ability to give away heat very fast rate. And if you design a very good thermal management system, which we did, then you can go very high temperature operation, because you cannot have the heat flux build up per se, and that prevents thermal runaway and an issue like that. As compared to in silicon, if you did so, probably you will run the risk of thermal runaway of the device, and then converter will get damaged. So I like to acknowledge my great friend Victor Bedialis, who's a director Power America. Victor was with me in India in February, and I took him a couple of places in India. He's a good friend of mine, so he just lent this slide to me to include in presentation. So with these unique property that silicon carbide gallium nitride has, silicon semiconductor doesn't. Because of that, silicon carbide gallium nitride device enable more efficient, lighter, smaller form factor power electronics operating at high frequency at elevated temperature with reduced cooling. What that means, reduced cooling, is that you can design silicon based inverter, converter, DC-DC converter, let's say inverter, up to 10 kilowatt air cooled. But with silicon carbide, you can go maybe as high as maybe 25 kilowatt. But if you take some exotic, air cooling techniques, we have proved that you can design converter up to 200 kilowatt, and you don't need to do any liquid cooling. And if you don't need to do liquid cooling, it simplifies the vehicle architecture. So those are the benefit that if you could mindful exploiting these benefit of semiconductor material, wide bandgap semiconductor material, you can indeed design very differentiating and very good power converter, much smaller footprint, much higher efficiency, and things like that. So before wide bandgap devices came along, became available, commercially available beyond engineering samples. Until then, either you can have a high power or you can operate converter a high switching frequency. You have seen that if you operate converter high switching frequency, size goes down, and for high power you have no choice. Certain applications you have to go high power. So as a result of wide bandgap, you can have both best of both worlds. Earlier, only silicon, either you can operate here or here. So here you were using silicon IGBT, which is more or less like advanced transistor, and then you are using MOSFET, silicon MOSFET. But with the silicon carbide, you can go high power at high switching frequency using silicon carbide MOSFET. As a result, you could get many applications. Those were not possible either cost effective or space effective, size, maybe failure mode, and things like that. Now all that became possible. I like to acknowledge, this slide I took from RPI program manager Isik Khijiali. So want to give credit for him putting his thought behind this. So now you understand the unique property of silicon carbide material. So you go higher voltage, that gives you increased power density. If you double the voltage, converter size goes down 1/4. If you increase the frequency, you can go higher bandwidth, means you can respond the demand of operator much faster. I explain high bandwidth or improved bandwidth like a 6-cylinder versus 8-cylinder car, or 4-cylinder versus 8-cylinder. So if you are driving on highway 4-cylinder car, you have to look at blind spot, then you have to again check if somebody came again, and then you change the lane. You give the gas and you change the lane, right? In 8-cylinder car, you just go, right? And you can accelerate very fast. Similarly, high bandwidth power converter can respond operator command to much faster rate. John Deere vehicle uses roughly 1000 Newton meter per millisecond torque change, which is extremely fast, right? So high swing frequency allows us to do that. High temperature allows simplified cooling system. High thermal conductivity allows improved thermal loading, advanced thermal management system. So for example, heat transfer coefficient from the die to the coolant, we have increased 5 times, from 20,000 watt per meter square Kelvin to we took it to 100,000 watt per meter square Kelvin. Means no matter how fast heat you put on, it just taken away. Very rapid withdrawal of the heat was possible because we exploited this property. And then another thing, since it is a high temperature and wider bandgap material, so it is less susceptible to failure due to cosmetic radiation. What that means is that oftentimes power converter electronics may fail just unknown reason, and that could be solar flare up, and can get some of the things get damaged. In wide bandgap based devices, no, so no such failure, and there's a lot of study has been done in this area. Higher critical temperature allows lower risk of thermal runaway, means semiconductor can go as high as 1000 degrees C, versus in silicon you can go 400 degrees C. So peak loading capability is much better, right? For 2-3 second peak loading. So one of the application could be vessel. So solenoid guns. Like a U.S. Army want to use these things for like a firing of the solenoid power gun, right? And that is basically one-time deal. You take it burst of energy. So it's a peak loading capability is exploited there. Engine coolant capable wide bandgap converter is possible because of all these unique properties. So until now, until silicon carbide came along, we were using our inverters are water cooled in vehicles. So we were doing 70 degrees C coolant, but now with the silicon carbide, we took 115 degrees C coolant. Means the electronic that is in the inverter, survives 130 degree ambient condition, and it is cooled with 115 degrees C coolant, and that became possible only because of the unique property of the material. And then since we eliminated dedicated cooling system, so we did simplify the vehicle architecture. In John Deere vehicle, there would be one cooling pack for engine, one for transmission fluid, third for inverter, then fourth you put a battery pack, and then it becomes so complex and so tricky to manufacture such a vehicle. So if you eliminate one cooling system, that's a very big deal for manufacturing and cost reduction. In addition to that, it eliminates the failure mode, because in the vehicle, the cooling pump, which is electric pump, fails often, and then that's a bad thing, right? That vehicle, $1 million vehicle, if it goes down per hour, is a $3,000 loss. So if we eliminate some of the part that are going to fail, then we get better product. So knowing the what you call the benefit of these two materials, Power America Institute was launched in 2015. US government put $70 million funding, and then $70 million cost share from company like John Deere and many others. And the objective was to promote US manufacturing, jobs, and energy saving. What that means is, if let's say all the vehicles and all that, if they become about 3% more efficient, then we can eliminate 3-4 nuclear power plant or gas fired power plant in US. So it's a significant energy saving. It's possible due to wide bandgap. And in addition to that, battery powered vehicle, right? The battery powered vehicle, the main thing is battery, right? It's not like somebody will come and charge battery in real quick, right? So you have to have energy efficiency is extremely important in certain applications, like a mining application, right? In mining applications, 50 to 70% cost is to keep the air clean inside the mine. So you could imagine that if you cut down the overall diesel consumption, or you put the battery powered vehicle inside the mine, then you can reduce lot of energy saving can happen, because you no longer need fresh air from the ground. So energy efficiency in certain applications is extremely important. So I was lucky to be part of this event. In 2014, President Obama came in North Carolina State University to announce, and only people who were seated there were the people who were leading this proposal, actually, that was submitted to the US Department of Energy. And Pro Leitner know it very well. Obama was, law graduate, right? He's a law graduate from Harvard, and he articulated power electronics so well, and all the techniques and tricks of, energy efficiency, high temperature operation so well, that if you guys are interested, just look at this YouTube link. You will find how nicely he articulated the vision of US manufacturing and US manufacturing job creation by energy efficiency. By the time he left office, he established about 14 institutes. So I was lucky to get invited in US Capitol Hill in 2018, and then interacted with so many smart people out there. One thing that was amazing to me, that each senator and Congress, House of Representative people, like elected people in the US government, which is legislative branch of the US government, are advised by smart people like MIT, Harvard, Stanford, PhDs, retired professors. So I felt very assured that all the US policy that are going to be designed by these lawmakers are pretty much nicely vetted out by the smart people out there. So now I'll talk about John Deere project in Power America. So we were given very aggressive goal. At that time, this was very new and nobody had done per se in the world. So we were given objective that we want to design 200 kilowatt, 1050 volt silicon carbide dual inverter. Dual inverter means in one inverter, there are one box, there are two inverter packaged together back to back. This inverter should be 97% and higher, will be lighter, smaller footprint, should have power density 25 kilowatt per liter. And as compared to conventional, we have a conventional hydrostatic 644 loader. As compared to that, electrified silicon carbide inverter base electrified loader will have a 25% less fuel burn. And then we want to eliminate the cooling pack for the inverter, want to combine that cooling pack with the engine coolant. So want to go 115 degree C coolant. So these were very, very aggressive goal in 2015. Where we exceeded that, in a power density goal much more. So we have converted 43 kilowatt per liter, and I can tell you, as for my knowledge, no one has such a technology and has tested on the vehicle. And then two inverter together over the temperature gives 98% and higher efficiency. So silicon inverter is roughly 92%, something like that. Silicon carbide is as high as 99% efficient. They began couple of generation of development work. So our Gen 1 silicon carbide inverter was good, qualified for 105 degree C coolant, and it ran 165 hot spot in the box. And Gen 2, same power, ran major data 145 degree C. And you may be asked that almost same operating condition, you increase the coolant 10 degree, why junction is less? The reason is that we designed very, very advanced cooling system. We took really advantage of thermal conductivity of the material. That's why we got this. And then the last objective is that we really want to compete with the current technology, though nobody's going to use these unless you meet the cost target. So this is actually the trend of the power density trend in the John Deere inverters. So this inverter is in 644 loader, and a variant of this is in 944 hybrid loader. So PD stands for power drive. 55 is 55 ampere continuous current, switch at certain switching frequency, let's say 6 kilohertz. And then the power density 9 kilowatt per liter, 700 volt DC was 70 degree coolant. And then little bit improvement, mainly from electrolytic capacitor in the inverter to film capacitor. Little bit improvement in the power density, but as soon as we use advanced material, advanced semiconductor, we got significant improvement in power density. In addition to that, we increase the voltage. So if you remember earlier, I was telling that if you double the voltage, converter size goes down by 4 times. That's exactly happened. In addition to that, if you could use some additional tricks, you can still get very small power converter, and that's exactly we did here. So as compared to this converter, this is actually 4 times less, right? It is much, much smaller. This weigh about 70 kilogram. This is under 9 kilogram, doing same job and maybe at a higher temperature and better. And we have reduced the capacitor size from 13,000 microfarad. Those who are power trans engineer must appreciate this, from 13,000 microfarad to as less as 440. So even we are using advanced material, costly power devices, but still we can meet the cost target because we took the system approach to reduce the rest of the componentry size, cost, and all that. So this inverter is now modular, can be used many vehicles, and the reason it is because John Deere never makes 1 million vehicle per year for one farm, right? We may be making at the most 1 million vehicle, all the vehicle put together. So since one vehicle is different from the other vehicle, so like Elon Musk's goal is to produce 20 million electric car by 2030, right? John Deere will never produce 20 million vehicle per year, right? Because there is no need for for such a thing. So since we have far fewer number each model, so why don't we use same inverter in many model and still produce these parts at least 100,000 part per year? And if we did that, we can certainly compete as compared to this old technology to this new technology. So new technology can certainly compete 10-year, 15-year-old technology, even despite costly components. Then power density gives us competitive advantage. Why I say so? Because when we had this inverter, we used to take to trade shows, and a lot of people were buying these buses, aircraft industries, and you name it. Once this came out, they stop asking about it. Oh, we need this one. Now they are saying, no, we need this one. So John Deere want to keep it this type too, at least because there's a lot of intellectual property in this inverter. So we don't want to give right away to also create competition. We put roughly $15 million to date to engineer this inverter from since 2015 to today. And then the decreasing size, cost, weight gives easier integration, means motor inverter can be put together. I tour factory where we make John Deere loaders, 944, 644 loader, and the vehicle goes many manufacturing stations. And sometimes it need to come back to same station 2-3 times because the manufacturing sequence steps, right? So if you reduce the size of your inverter and all motor, and make that what you call you don't need to come back to same station twice, thrice, then that gives you manufacturing simplification, reduces manufacturing cost of the vehicle. Improve performance and high temperature gives us system benefit. So all these put together gives unique differentiating advantage in silicon carbide, which were not in case of silicon technology. Why off-highway vehicles are very different? Because requirement of near zero speed operation. Because as you said earlier, we are hitting some objects, so it has to stop. And near zero speed is extremely taxing for power electronics. Just to give you idea that you take a power converter, if let's say you are 100 kilowatt converter, 100 hertz, fundamental frequency, switching 10 kilohertz, you back off the fundamental frequency from 100 hertz to 10 hertz, and if you did so, you will find that the 10 hertz operation is much more severe for power converter. Converter will operate much higher temperature, and the reason it is because now converter switches are remaining peak load condition for longer duration. So you are not allowing this to relax as you were doing, and you are not like heat flux build-up type situation, if you will. So near zero speed operation is extremely taxing for John Deere vehicle. It's not a highway, right? Like on road, like you start your car and you go, right? You have to continuously stop, start, and that is not good for the power electronics. So this is 644 loader. It has basically engine is coupled with the generator. Generator drives runs in the voltage mode, and then it puts power in the inverter. Then 644, traction machine has its transmission system, and if any time you are slowing down and you couldn't control the voltage, you burn the electric energy into the power register. If we could do engine cool and capable power dense silicon could simplify vehicle architecture, could basically reduce the engine size. Like for example, we have a 644 hydrostatic drive and also the electrified. So hydrostatic uses a 9-liter engine, electrified uses 6.8-liter engine. With the silicon carbide, we expect that we can further go down engine size 6.8 to 4.5-liter engine. So what that means is you just take the advantage of energy efficiency and reduce the engine size. Why it is very important? The reason it is important because once these vehicles are turned on, they remain on for 22 hours. So when the operator changes the shift after 8 hours, then vehicle may be idling for half an hour, just doing nothing, burning fuel. So smaller the engine, lower the idling fuel burn would be, and that helps. So these are the kind of benefit you want to enjoy, so that you can introduce a differentiating, which is a little bit costly technology but energy efficient. A lot of people ask me, okay, these are hybrid vehicle. Why, how much, what is the battery size you guys are putting in these things? So just to give you idea that 644 loader, hybrid loader burns about 5 gallon diesel per hour. You just cannot have battery because 1 gallon diesel has a 275 kilojoule energy, means one diesel gasoline actually one gallon diesel has that much as much as energy. If you could release in a microsecond or nanosecond, it is pretty much like a nuclear device, but there is no such technology found to date that you can quickly release all the energy content in just in 1 nanosecond, 10 nanosecond, right? So it's a huge energy in one diesel that is not possible to replace by battery, right? So what we do, we put the engine, and then we have the gearbox, and then engine spins at 1800 rpm, gear, then generator spins 5400 rpm fixed speed. So what is it going to do? It is going to run, the engine is going to run a constant speed, and that basically makes the engine efficient, because now you are not all over operating the engine, over the speed. You are operating at a constant speed. That makes engine durable, reliable, and efficient. And then you could basically generate the electricity, and then traction system has what you call the 3-speed transmission system. And if you are slowing down and you couldn't keep the DC bus voltage, then you burn that energy into the power register, which is actually glorified water heater, if you will, 150 kilowatt water heater. But it is needed. Reason is that because this vehicle start and stops 4 times in 2 minutes, and every time we found that there's some energy going into the power register. So we are planning to replace this with the battery, and if we did that, then the idea that we would further downsize the engine. Another thing is that since now the engine is decoupled from the traction system wheel, so basically the operation of the bucket, right? So operator can pay attention to the work rather driving the vehicle. So because of the electrification, the vehicle has become more productive and performance. So it's energy efficient, it's more productivity and better performing vehicle. The thing is that, like suppose somebody has a mining operation, uses 4 vehicle. With electrified vehicle, that same job can be done by 3 vehicles. So essentially those are the benefits that you need to pass on to introduce a costly technology which is energy efficient but costly, at least initially, and then people adopt. So people have a lot of good thing to say about this product. So we gone 3 generation of development of silicon carbide. So what we did was we took the PD400 inverter, which you saw earlier, retrofitted with silicon carbide power module, and then tested gate drive, tested capacitor, motor, insulation, and all sort of things that we wanted to do with no knowledge in case of in the area of silicon carbide. Within 9 months, we were spinning the electric motor with the silicon carbide inverter. Why I'm saying so? Because when you are working on a risky technology and you are pouring millions and millions of dollars on your research and development, you want to make sure that if there are any risk, like that this technology too early, not mature enough, then if you have a risk of failing, then fail fast and move on, versus keep putting your resources. Like a time is not a problem. Sorry, the resource is not a problem. You can earn back money anytime. Problem is time. If you lose your time, then you lose competition, right? So that's what you don't want to put your engineering resources on doing something that may not be useful for you, right? So what we found within a 9 months, we found no, it is a go, and we can indeed work on such a thing. So this platform allows us to answer that very difficult question. Because if management asks me, hey Bridge, this is good to go, my answer was no, I don't know, right? But 9 months later, yeah, it is good to go. Let's keep working on this. And then we did our Gen 1 inverter. did some improvement on this, and this is our Gen 2 inverter, which is simplified, much lighter. So like, for example, this weigh about 40 kilogram and this is under 9 kilogram. Very easy to connect on the vehicle, all that. So manufacturing advantages are there. In addition to that, inverter is so small, the inverter motor can be put together. We can eliminate the cables and all that. So if we eliminate cable, we eliminate plastic, we eliminate copper and all that, which is good for environment, right? So we really want to be mindful, environmental friendly manufacturing, environmental friendly design for our product, so that we can remain business over here. We don't want to basically dump our carbon footprint or carbon, all those greenhouse gases in the environment. So just a little bit more detail on the Gen 2 inverter. So we tooled this power module. So in 2017, I had about $500,000. So I funded GE Aviation System. There's a company, it's a GE branch of, aviation branch of GE. And GE Aviation has a world best class engine, actually, jet engine. And those guys are also doing some powertronics. So I funded them that I want to develop a power module. So they eliminated wire bond and they put all the 6 MOSFETs in the module. Not only that, they integrated bus bar, they eliminated voltage joint and all that. And then that's how it did the trick. That converter is such a small and very easy to manufacture on the vehicle. And then the inductance between both drive generator and traction means is much less, so you can reduce the size of capacitor. You can respond to operator command much faster rate and things like that. Anytime we use these power module, we basically test them over the temperature. So we test them at -40 degrees C, 0 degrees C, 25 and 105 degrees C. And the reason is that because material property can change over the temperature. So you want to understand that over the temperature it's going to work fine, right? So that's why we do. And then the design that is settled on that should work over the temperature, a span of at least 200 degrees C. So you want to make sure that electronics that you are designing should work fine at -40 and should work fantastic 130-degree condition also. Then we basically compare these two loaders. So this is actually production loader, uses PD515 inverter, 9 kilowatt per liter, 70-degree coolant, and use a dedicated cooling system, cooling pack we call this, for the inverter. This one uses engine coolant, and we needed to modify the architecture and run the engine coolant through it and modify the cabinet. So as the operator is climbing in the cavity, goes through the he's put his steps on this here on the ladder inverter right here. Our vision is that to remove inverter from here, put in here, and that is possible with our Gen 2 inverter. So new generation of 644 loader that may come in future may not have this, may not have inverter here, rather inverter is here. And once you put it there, then you are talking about 105 degrees C ambient condition, 105 degrees C coolant condition. So the stringent condition on the electronics are far more severe versus that where with this inverter. Some key lesson learned over 4-5 years, that IGBT mindset, silicon semiconductor mindset doesn't work. You need to pay attention to over voltage. You need to pay attention to cable, machine insulation, all that, EMI, EMC, bearing current. So oftentimes a power trans engineer tells, okay, I'm going to put it, and then I'm going to put a snubber capacitor. I'm going to put a decoupling capacitor to control the voltage. That's a wrong approach. You need to design packaging in such a way that you never need decoupling. It's like a eating pill for blood pressure, and that gives you another problem. Then you are eating pill for that, and that gives you another problem. Then you're eating pill for that, right? So you want to make sure that you don't need to take pill at all, right? You want to remain healthy, and that's basically the idea here, that if you do packaging, such a good packaging, then you can eliminate the over voltage. That's exactly we did here. So we've designed package, power converter package in such a way that over voltage is almost gone. And if over voltage is gone, it is very good for machine insulation, bearing current, EMI, EMC, Otherwise, you have to do so many after treatment for your product that it drive the cost up, right? So you don't want to do all those things after the fact. You want to design right from the very beginning that you don't run into these issues after the fact. Then we took the things for vehicle testing. So if you remember, I told that I reduced capacitor from 13,000 microfarad to as less as 440, and actually simulation, hardware in loop simulation, Simulink simulation indicated that we can go as less as 280, but I said let's go with 440. Anyway, so how I know that 440 is good? Because earlier I had a 13,000 microfarad. Now I have very small capacitor. So we did lot of testing in the laboratory environment. Means we run multi-machine, multi-inverter setup, and then we have two outer inverter, right? They are supported by a DC source, which is power supply, but inner inverter, two silicon carbide inverter back to back on same box in PD in our Gen 2 inverter. So they do not have any external source, right? And that's how you test this thing. So essentially what happens, the first two inverter motor together are simulating engine driven generator, and the other two are simulating traction system. So what this setup is going to do, you pretty much simulate everything like in the laboratory environment, like you are driving the loader, like a driver is operated driving the loader. So what it helps us, like it helps us improve our software, it helps us eliminating field issue that we don't know that may occur so very early on, and then the product that gets on the vehicle, we don't need to run any issue, because once it gets there, it's very difficult to resolve. So such a technique helps us a lot. And then we have 14 such setups in Fargo, North Dakota. So we do a lot of testing. And another thing, on the test, speaking to testing. So if you have $100 and 10 year, I would put $1 and 1 year on the design, and remaining resources, remaining time on testing. Because unless you know your product, unless you know all the operating conditions, it is very difficult to perceive that how it will work in the field. Like imagine that in hot summer in Arizona, you're working and you never know that one corner condition can fail the vehicle. And as I said earlier, failure is not option. So how we eliminate all those uncertainty by testing. This is how that setup look like in reality. So this is our Gen 2 inverter drive these two machines. This is our PD400 inverter drive these, and then we cool the motor with the automatic transmission fluid ATF, and we cool the inverter with the water. So all this setup and all that is there, and we do lot of testing, like pretty much testing done in the laboratory, like you are driving the 644 loader. As I said earlier, operator does whole day long. He puts high power, low power, high power, low power, 4 times in 2 minutes. So we want to make sure that the DC bus and inverter remains stable, no instability issue and all that. And we tested that. Then our Gen 2 inverter, same thing we did that testing, found with a very small capacitor from 13,000 microfarad to 440 microfarad capacitor, we remain stable, no issue whatsoever. And then we took it on the vehicle after having felt confident that indeed we can operate 105 degrees C coolant through inverter. Then we put inverter on the vehicle. So this is Al Hafner. I grew up reading his research paper. When I was a student in IIT Delhi, I used to read his research paper, Victor Bedialis. These two, and these guys are Power America, management people. Lockheed Martin, my friend Tom Bird came from Lockheed Martin. They want to use silicon carbide in defense products. And this is me, and then Kevin Binion. Actually, Leitner, he is in Colorado. He is in National Renewable Energy Laboratory. So if you ever want to go visit them, I can arrange your trip there. So, so essentially that all of them came, they drove 644 loader, they drove 944 loader, because 944 is very impressive. Why it is? Because look at the tire, right? I think one tire may be costing 10,000 plus some, right? And so in 944 loader, electrification did one trick, which little later you will see. that we can stop the wheel spin. So as it is operating in the mining operation, you don't want to let the wheel spin as you are pushing in the mine, right? You are operating 0 speed, and if wheel spins, then it can ruin the tire, and 10,000 tire is gone in one shift. That's not good. A lot of people can lose their job, right? Another thing we found, the benefit of electrification. you know Earlier in US, lot of farming kids, like farming kids are really, they are not scared of big stuff, right? Because they have seen right from day one when they were born, right? When they at least don't know, they know what their mom and dad are doing in farm. So they came in this trade, like a operating construction, mining vehicle, all that. Not anymore. So electrified vehicle can any unskilled operator, if you give him or her, within a week, he or she would be expert in operating these vehicles. So that's another huge benefit, which is social benefit of electrified vehicle, if you will. So I'll play a video here, which is 644 loader. Pay attention to tire slippage. It is driven by silicon carbide inverter that is cooled with the engine coolant. I think I need to rush it through because I'm running out of time. And this could be my last 1 or 2 slide, and then I'm done. So as operator is pushing this loader in the pile, tire is slipping, right? 944 loader, we cannot allow doing that. So we have a trade secret on that, and the idea there is that do not allow tire slippage, otherwise you ruin the tire and then you need to replace very costly tires, right? Which is, again, think about from environmental standpoint. If you need to replace these guys, which is not good. Okay, so now it's like my last slide. So we need to be mindful what trends we are watching. So target, we are niching power density, capability, performance. So power density are heading in right direction. US Department of Energy next goal is 100 kilowatt per liter inverter. So when they found out that John Deere is already doing 43 kilowatt per liter, they thought, okay, let's bump up the power density objective or goal. And then that's how they fund the company like Deere and many other companies in US. Also, the engine coolant operation, we proved it out, 105 degree and 115 degree C coolant, superior performance, energy efficiency to inverter, not only 98% at 25 degree, but over the coolant efficiency is very high. And we are trending towards that we can compete with the current technology. So in summary, silicon carbide technology is real, early adopter likely to be niche application. Like I said, mining operation could be where energy saving could be because you have less electricity burden to keep the air clean inside the mine. If you have energy efficient vehicle there, it could be by 2025 time frame, you will see a lot of vehicle. In fact, Tesla Model 3 car is a silicon carbide based car, and there's many automakers are putting silicon carbide based vehicles out there. Porsche and so many of them, battery powered vehicle, all of them will have a silicon carbide technology. And John Deere, my personal basically take on this is that silicon carbide MOSFET will obsolete silicon IGBT actually, like it will become like a thyristor of today. And then John Deere has significant experience. We can compete with the silicon technology, and we did innovation by what you call 9C solution. We reduced capacitor, we increased the coolant temperature, we simplified connector, we reduced the size of inverter, we developed very advanced control techniques, we did coreless current sensor, because core-based current sensor was having issue, heating and all that, copper cable and cost and all that, we addressed those issues. I would be happy to take questions. And also before I did that, I like to acknowledge U.S. Department of Energy for funding this project through Power America and National Renewable Energy Laboratory scientist Kevin and his colleagues there, and of course John Deere management and my team in John Deere. Thanks for having me, and I would be happy to answer question you may have.
If any of the guests have any sort of questions, you may post in the chat section. Sir, I have a personal question asked by another person. Which semiconductor, silicon carbide or gallium arsenide, is better for high power inverter technology?
So both have their role cut. So gallium nitride is good 650 volt and below. So like a 10 kilowatt type converter, unless you want to go multi-level gallium nitride converter, you can go indeed high power. But people are working on vertical gain that can go high power. But currently, whatever technology available, gallium nitride is good 650 volt and below, up to 10 to 15 kilowatt. And silicon carbide, you can go as much as 1 megawatt and higher than that. So high power, high voltage silicon carbide, up to 15 kilovolt MOSFETs are available. Engineering sample production, like a commercial parts are available up to 3.3 kilovolt MOSFETs. In the 1700 volt, 1200 volt MOSFETs are readily available. In case of silicon carbide, gallium nitride 650 volt and below. So high power silicon carbide, high voltage, high power silicon carbide, low power, low voltage gallium nitride.
Thank you, sir. There was another question. Can WBG semiconductor be used in medium voltage applications?
Yes. Yep, you can basically. So like for example, 10 kV MOSFETs, people are designing, 6.5 kilovolt DC bus converter, 4.5 kilovolt DC bus converter. Yeah, so that's basically the idea, that medium voltage devices. But unfortunately, ampacity is not very high at the moment, but people are doing some paralleling. I know some of the people are paralleling as many as 32 MOSFETs in parallel. So there are some challenges people are overcoming, but yes, silicon carbide MOSFET would be very good for medium voltage applications.
Thank you so much, sir. That's all the questions we have received so far. Thank you so much once again for providing us with a cross-dimensional perspective on such a multifaceted topic, that is wide bandgap power electronics for heavy-duty vehicles. We are deeply indebted to you for taking a significant portion of your time amidst your very busy schedule to join us here. We, on behalf of IEEE Kerala Section, would like to present a small token of appreciation for your services.
Thanks for having me, and it was a great pleasure. And Professor Leitner, I will catch up with you later sometime. Yeah.
Thank you once again, sir. Before we move on to the next program on the agenda, I request all the dignitaries and guests present here to kindly turn on your videos so we could have a short photo session. Once again, I would like to request all of you present here to kindly turn on your videos.
Shankar sir.
Shankar sir.
Yes, I'm here.
So we can take the photograph, right?
Okay. So I request everyone to quickly turn on. Sabina ma'am, you are darker. So I request everyone, I will count from 3 to 1. And if everyone could say IEEE and hold that last T for a bit, we can have a great snap, as usual. Okay, yes. So I request everyone, Akash Nair, your video is off. So So on the count of three, 3, 2, 1. IEEE.
IEEE.
Okay, thank you. Thank you all. I will just check a moment. So thank you all. All look wonderful. Thank you. Thank you for your time.
Thank you, Shankar sir. Thank you, everyone. Next up, we would like to present a message with omniscient insight from Ms. Leila Di Floriani, Professor, University of Maryland at College Park, USA, and 2020 IEEE Computer Society President.
Welcome everyone to the 5th edition of the IEEE Kerala Section International Conference on Recent Advances in Intelligent Computational Systems. What an appropriate theme you have selected this year, computational technology for a healthy humankind. It aligns so nicely with IEEE tagline, Advancing Technology for Humanity. It's excellent that despite the global pandemic, you are able to come together virtually to engage, learn, share, and hopefully make some new connections. I would like to thank the IEEE Kerala section for inviting me to welcome you to the conference. A big round of applause goes to the conference chair, Mr. Satish Babu, and the entire steering committee for putting on such an extraordinary event. It's clear that everyone has put so much energy into organizing this year's conference, as we can see from the high quality of the program. As you are aware, the IEEE Computer Society is the world's largest and most influential global membership organization of computing professionals, representing a community of more than 100,000 people with more than 500 professional and student chapters in 168 countries around the world. Programs like our more than 200 international conferences, the increasingly growing and highly cited digital library, our long-standing commitment to standard development,
Dina, if there is a problem in the playback, we can have this tomorrow. Please go ahead
portfolio
with the next
make the IEEE Computer Society the leading provider of technical information, community services, and personalized services to the world's computing professionals. And it's because of volunteers like Satish and the rest of the organizing committee that our activities are so successful. So again, thank you for your time and energy. You have an exciting agenda in front of you. I hope you enjoy your time together and make some new IEEE connection. Thank you.
Although she is not present here currently with us, I would like to extend our sincere gratitude to Ms. Leila Floriani for her wishes and support. In grateful acknowledgement of spirited efforts and contributions of many individuals, I feel privileged to extend my warm welcome to Dr. Bobby Phillip, conference convener, to deliver the word of thanks.
Good evening and good morning to all the persons attending this event, wherever they are placed in the location globally. Honorable Chair of IEEE Kerala Section, Engineer Sharda Janishram Madam, who is chairing this function, is presiding over this function. Respected Professor Michael R Leitner, Fellow IEEE. Respected Dr. Brijan Singh, respected General Chair of this conference, Engineer Satish Babu sir, and other distinguished dignitaries and participants attending this function. It's my privilege to be here proposing vote of thanks at this magnificent technical event of IEEE Kerala Section. I wish to thank first our engineer Sharda Madam, who is the chair of IEEE Kerala Section, who is presiding over this function, and she has delivered a good talk and message for the conference, and initiated the proceedings. And she has been supporting us with all the resources of IEEE Kerala Section. And on account of formality, I thank her on behalf of organizing committee of the conference and the IEEE fraternity in Kerala. I thank her for the nice words she has spoken during this function. Next, I'd like to next person to thank is, of course, our respected Professor Michael R Leitner, fellow IEEE, whose talk has really enriched this evening, and it was very close to the soul of India. It touched many aspects, and in fact, he once again reminded us of the significance that we have to include the aspect of the humanitarian side to the development of technology. And he also talked about the holistic approach to the well-being of human being. So your kind words about Kerala and India really inspired us, and we take that to close to our heart, and we thank for a nice and a very thoughtful talk, and for agreeing to deliver the inaugural address and to officially declare this function, this conference open. I thank on behalf of the organizing committee and the IEEE fraternity in Kerala. I thank you, sir. Next person to say thanks is the speaker, the keynote speaker of the conference, and he has worked in very upfront technologies, and he has given a very enriching talk, and he has showed some light on recent developments in power semiconductor devices for heavy duty vehicles. And he answered the queries as well. I thank on behalf of the organizing committee and the IEEE fraternity in Kerala. I thank Sir Sir for a nice keynote address. Next person to thank is the general chair of this conference, Satish Babu sir, who has been there building up the conference for from the very start. And as you all know, this is a difficult period. So in the time of COVID-19 and pandemic, it was a tough task, and his leadership has really worked here, and he was behind all the happenings. I mean, he was very actively monitoring and constantly encouraging the team to carry out the task in time and in a very efficient manner. And I thank, on account of formality, on behalf of the organizing committee and IEEE Kerala Section, I thank Satish sir for the leadership that he has shown and the support he has given to all of us. Next person to thank is today is our technical program committee chair, Vijaya Madam. Dr. Vijaya Madam. She has given a nice introduction about the proceedings of the conference, and she showed some light on the talks, events that are to come tomorrow and day after tomorrow. And she gave a brief history of the conference. And I thank, on account of formality, I thank Vijaya Ma'am on behalf of the organizing committee and IEEE fraternity in Kerala. And along with her, the Vice Chair of TPC, Dr. Jisha Via. She was also very actively monitoring the, coordinating the activities. On account of formality, I thank her also for the contributions she had made to make this event a very success. And next person to thank is Engineer Suhesa, who is the chair of IEEE PS Kerala chapter, and he has introduced the keynote speaker to the audience, and he gave thoughtful messages as well. I thank him also for coming over and gracing this occasion and representing various societies, as Bijana ma'am rightly pointed out. This is a joint effort by various technical societies in IEEE Kerala section, and representing all of them. He was here. I thank him also for gracing the occasion and introducing the keynote speaker. And next person to thank is Professor Dr. Suresh K. He was the chair of Publications Committee, and today he introduced that proceedings of the conference, and he has tirelessly worked over the last few weeks along with Vice Chair Dr. Jason Matthew to bring out a very good document out. I thank him also for the contributions that he has made for all of us. And next, I would like to thank two persons who were actually actively participating, integrating everything, and it's none other than Professor Nandanas, who is the chair, finance chair of this conference, and he also tirelessly worked over many weeks to take this conference to this shape, and along with him, Professor Shankar, who was also coordinating many of the activities like registration and publicity, and he's the publicity chair, Professor Shankar also. I thank both of them for the contribution, really great contributions that they have made to this, to make this conference happen. And along with that, the leaders of various societies of IEEE Kerala section, who were working with us in one way or other to make this happen in a short time, that too in a very difficult period. I thank them also on behalf of organizing committee and the IEEE fraternity in Kerala. I thank them for helping us to bring this conference to this state. And next, I wish to thank the young professionals of IEEE Kerala section and the young, vibrant volunteers, student volunteers of IEEE Kerala section, who has really worked behind the scenes, and they are actually working they are supporting the backbone of this conference, like the online meeting arrangements and all. And they're taking great pains to do it in a very excellent manner. I thank all of them. I'm not naming anybody because there are many people who are working there. So I thank all of them for their contributions to make this conference a grand success, and especially this function, a great success. And as time is limited, I am concluding this. And if by mistake I left out anyone, I use this occasion to express my sincere thanks and appreciation to all of them. Who it's actually a very work which is involving a lot of individuals working in different parts, located in different geographical locations in Kerala. I thank all of them for their contributions to this event. With that, I wish to end my talk and hand over the mic to the computer. Thank you. Thank you.
Thank you so much, sir. IEEE RAICS 2020 is designed to provide opportunities to discuss, to debate, to obtain new insights or ideas, to network, and to be an important part of your current and future success. I would like to extend heartfelt gratitude to everyone that have been involved in the organization of this program for their dynamic efforts, and all the honorable dignitaries who have graced this occasion with their presence. Thank you to all of you here for joining us. Although IEEE RAICS 2020 cannot be held physically, we hope that all of you would experience the full-fledged integrity and quality of the content in this virtual environment. Thank you for your support of our shared mission to advance technology for humanity. And with this, we mark the end of the inaugural ceremony of IEEE RAICS 2020. Thank you once again.
Thank you. Thank you, Dina.
Thank you.